I'm going to do a quick rundown on the basics of BASIC. Um, BASIC is a pretty standardized language that will probably run on other platforms as well, so some of these lessons may apply to other computers or operating systems. Of course, instead of using a hardware Commodore 64, I will be using the VICE emulator, which you can find here, vice/emu.sourceforge.io. Um, and when you fire it up, it looks like this, exactly like it would have on the hardware computer 40 years ago. I said in the previous tutorial that if you're in full screen mode and you want to get out, you can hit Alt Escape. However, if I go back to VICE, again, it's still in full screen mode. If I want to exit full screen mode to go to normal mode, I can hit Alt D, and that minimizes it. I can switch between Alt D to maximize, Alt D to minimize, like that. Okay, when the Commodore 64 first fires up, it's running BASIC. Commodore 64 BASIC version 2. So, and you can type commands right from the command prompt. I remember my landlord years ago had a used one that he let me play around with it, and I turn it on and I get this, and then you of course you try everything. Hello, error, run something, all you do is get a lot of error. So the computer wasn't much good by itself unless you had a manual or a book on BASIC. Okay, so another nice thing, let me go Alt D here, about the emulator. In the old days, if you did something, you can go down and overwrite some bit of memory that will mess up the way the computer is working, and you would have to turn it off and turn it back on again. But with the emulator, I could just go reset like that, and it takes it right back as if you had restarted the computer. So let me go Alt D, I'm in full screen mode. So let's do a little Commodore 64 BASIC here. So I could type a print command and just say print 1, and the computer prints a 1. I could also go print 1 plus 2 there, and it prints the solution. Also, let's say I could go print 2 for multiplication, use an asterisk. 2 times 5, there's your answer. Or I could also, by the way, instead of typing print for a shortcut, you can just use a question mark. Print 42, like that, say, just for shorthand. So continuing along here, I could go print, let's go 2 times 5 plus 3. And there's the answer. Now observe that it uses an order of operations. So if I were to do, let's say, print 2 plus 3 times 5, you see it does the multiplication first, then the addition. That's the order of operations. Now let's say I wanted to print some text to the screen. If I went just went print hello, I'd get an error, or it wouldn't print what I told it to. That's because this is a text which needs to be a string. In order to define a string, I have to put it into quotations. So it'd be print quotation hello, like that, and the computer prints hello. This time I'm going to actually write more than one line of code. So I could do a single line of code right from the command line. If I want to do more than one, I tell the computer I want to write a new program. Now I'm in program mode, and the lines of code need to be numbered. So I'm just going to start at number 10 here, and I want to define a variable, and that variable is going to be stored in an A. So I could say A equals 42, and then line 20, print A. That's it. So now I'm done writing my program, so I can just type run, and there, it prints the variable to the screen. Okay, let us do another one. I'm going to type new, type another program, this time 10, s equals 3 plus 4, 20, print s. Let's run that, see what we get. There you go. So you see it goes ahead and does the math for you, stores it in the variable, and then when I call the print command, there is the answer. Okay. So let's do another one here. New 10. I could go A equals 1, 20B equals 2, 30C equals A plus B. And then let's print it to the screen. Print C, like that. Okay, so we'll run it. There. So here I've done some math and stored it in a variable. Here I've done the same thing. I've declared two variables and then added them together into another variable and printed that to the screen. Let's see. Now let's say I want to store some text in a variable. So I wouldn't just go A equals hello, because this is a text string, they call it. So in order to define that this A is a string, you put a $sign like that. A equals Bob, like that. 20, I could say print hello space, and then right on the tail end of that, I'm going to use a semicolon and print my variable $, like that. So let me go run my program, and I get hello Bob. Okay, so let us continue, shall we? New program. Now you can write little notes to yourself in your code. So I could use a REM for reminder or remark, whatever works for you. We'll say that this is names of fruits. There. So when the computer compiles the code, which it does at runtime with BASIC, it will ignore anything with the REM in there, right? So let me go say print orange, line 30, print, say bear here, and 40, print apple. There. So let's say I've got my program and I run it, and only then do I see that I have made an error and I want to go back and change it. How do I get back here? Well, let me go list my program. There it is. So now I could just go arrow key up, arrow right until I'm right over the bit that I want to fix, enter the new bit of code, enter the P in this case, and then hit the Enter key, and it has made the correction. So now I could go down here and type list, and you see that the code has been updated. I can run it, and there is my fixed bit of code. Now, oftentimes in BASIC, you see how I've gone 10, 20, 30, 40 instead of 1, 2, 3, 4. The lines do need to be numbered, and oftentimes the reason they'll go 10, 20, 30 is maybe I decide later I want to put some code here. You know, I can still do that because I have some space numbers between 20 and 30. So let me go 25, print grape, and hit enter. And now if I list my program, you can see that there is now a new line of code inserted there. I could also, let's say I don't like pair or I want to update my code. At this point, I could also overwrite that line just by typing over like that. And now when I list my program, you see that it is overwritten line 30. Let's say later I don't want line 25 in here. Well, to get rid of that, I just go type the line number and hit enter. And you see it has overwritten a blank there. The line no longer exists. I could also, let's say I want to insert a bit of code here. I'm going to go here to over the A, and if I hit Shift Insert, it will back up. And if I hit Shift Delete, it will add lines. So I could replace that way. So I'm going to go Shift 1, Shift Delete. Whoops. Nope, nope, nope. I'm going to insert. I'm just going to write pineapple like that. There. So if once you hit enter, it will overwrite that bit of code like that. I can reuse my R here, type run, there. Whoops, and again, another mistake there. Let me just go down here and list pineapple. I could go over here to my P, and I hit Shift Delete, and that added a line there, and I can make my correction. Added a space, not a line. Now all I do is hit enter, and the update is saved. Go back down here and run my program, and there, the changes have been fixed. What else can we do? Let's do a new program. I'm going to go 10, print an A, and then I want to put a little space between this A and the next bit of typing. I can say space SPC 3 like that, and then number another string. I'm going to just put a number in a string. It's not stored numerically, it's stored as text. And hit enter and run my program, and you see 1, 2, 3 spaces between the A and the 8. 1, 2, 3. Correct. There we go. So another thing now, I've got all this code on the screen here, and maybe I want to clean it up. From the command line, I could just Now, if this was a real Commodore 64, there's a key on there to clear the screen. You just hit clear screen and it clears everything and starts over. But from an emulator, a way to do it would be to go print CHR dollars and then in parentheses 147, enter there. And it clears the screen and everything's all fresh and new. I could do the same thing in a program, like I want the computer to clear whatever is already on the screen before your program starts. So I could go, let me start on line 100, print CHR dollars parentheses 147, like that, and next line of code, let's try, I'm going to define the amount of space in a tab. So let me go 10. Sorry, space, print, tab, 10, like so. That will say how far the tabs or the columns are apart from each other. Let me just demonstrate A, B, C. I'm going to go tab 100 D, E, F. Close the quotations. I'm all done here. Let me run my program. There. So I have defined how far the tab is. And so I'm 10 spaces in on ABC and then another 100 spaces to DEF. All right. So let us type a new program. New. Let's say I want to have the user type something into the computer and input it into a variable. So the way that's done, 10, line 10, you type input, and then the name of the variable you want the input to be stored in. In this case, I want to store a string, so I want to define the variable as a string. Go 20, print, you typed in, and add an extra space at the end inside the quotations, and I will use the semicolon and then call on the string variable that we've just input. Let me go ahead and hit enter and we'll run that program. Okay, so it's displaying a question mark. That means that the computer wants some input, you know. So I'm just going to say yo, and when I hit return, it prints out the variable. So here I've put two commands on a single line, print this bit of text, and then right on the tail end of it, using a semicolon, print the string variable which the user has input. Okay. So I could also, let me input a numerical value this time. I'm going to go new program. We'll say this time input, let's say x, comma, y. X, comma, y. Okay. Whoops. What did I do wrong? Anybody spot my error? I didn't number the line of code, so I'm just going to 2, 3, use a shift delete to insert a bit of space there. There's my 10. If I hit enter, then the line of code has been updated. I can now go print that out. Let's go 20 print x comma y. There's my little bit of code. Let's run that. So it wants some input. I'm going to just type, it's looking for a number, so I'm just going to put in a 4 and hit enter. And now it wants some more input as defined by the comma. So I'm going to put a 5 there. It prints 4, and because there's a comma, it goes to the next tab, next column, and you can have 4 columns. I will show you that in a second. So let me list this program here again. So I could also here, instead of the comma, I'm going to use that semicolon as I showed in a previous snippet here. Enter to overwrite it. I'm just going to reuse the R in ready. Let me arrow ahead, backspace or delete back. Right, un for run, and it's asking me for this data. I could also just go 12 comma 42. See, so if you only put one input of text, it will ask you again for the next one and the next one and the next one, or I could just enter them separated by a comma. You see, okay, so, and now this time it didn't use the full tab because I used a semicolon instead of a comma, right? Okay. Next, let's say, let me type new. I'm going to say line 1, input W, comma, X, Y, and Z. Now on line 10 here, I'm going to say, define a new variable, T equals W plus X plus Y plus Z. And let's go 20 print total equals, I'm not going to put the space in there this time, semicolon T. And we'll go run that there. So it's asking for a number. I'm going to say 4, 5, 6, and 7. And then when I enter, it totals the values. To run the program again, it's still in memory. As you know, I could type list to view it, but that program is still dormant in memory. To run it again, I could just type run again. There, see? So I could go 1, comma 2, comma 3, comma 4, and there's my total. See? So same thing with string values. I could also, let me type new 10 input. And now instead of just having a question mark there, you know what that means, but maybe the end user, whoever you're writing the program for, doesn't. You might want to print some text on the screen for a prompt. So we'll just say enter any 4 names, and let me go semicolon. Now, since I'm going to be entering text this time, I want to say A dollars, B dollars, C dollars, D dollars. Okay, and enter the next line of code. Maybe I want to skip a line in the program. And one way to do that would be to just print an empty bit of code, an empty string, or you could just plain call print, you know. So here we go. Let me go 30 print A dollars, B dollars, C dollars, D dollars. Okay, there's my program. Let me run that. There. Enter any four names, and it does automatically tack on the question mark whenever it's looking for input. But at least now you have a prompt there so the user knows what to do, you know, so I could type. And I don't have to use the quotations now to enter Bob, Doug, Uslid, whatever, and Joe. Enter. There. Okay, here it outputs the four text strings that I have input. Okay. Okay, that's a little bit of basic. I'm not going to get too deep into it. I was drawing primarily for these lessons from a book called Learn Basic Programming in 14 Days on Your Commodore 64. Pretty simple, straightforward, easy to read and understand book. Here's an address, you can find it, or just type Learn Basic Programming in 14 Days um, into Google, and it exists in a number of different locations. You know, great book, easy to read, easy to get started. You know, so highly recommended. There's plenty of books out there. I swear to God, they would just hand out computer science degrees to anybody that could hit the on button on a computer back in the old days. And there's a plethora of books that were a complete waste of trees, you know. But this one's a good place to start. Okay, so let me just wrap up this tutorial here then.